assignments you missed, but this is our formula. It recorded for 30 minutes, Addison. Okay. All right. So AP loves to give you problems that look like this right here. Okay. So you cannot find the inverse because it doesn't even have the inverse available. Okay. So no. So this is, we just found, because this uses inverse notation, I'm going to use that notation here as well in that formula. So F inverse prime of X is 1 over F prime of F inverse of X. So this is a formula that you are going to need to have memorized. Okay? Okay? All right. Okay. So I'm trying to find F inverse prime of 7. So my X here, I'm just going to erase this X right here, and I'm going to put a 7, which means I'm also over here going to erase this X and put a 7. Nope. Addison, stop. Okay? All right, so F inverse of 7. That's what we got to figure out first. Daniel, put your mask on. Okay. Sorry. All right, so F inverse of 7. Okay. What is F inverse of 7? No. These are primes, right? These are primes, not negative ones. It is 4. Because right here, our y coordinate is 7, so the inverse would take us to 4. So F inverse of 7 is 4. So we're looking for where the y is 7, and it's going to be the x of the original function that goes with it. So we're going to have 1 over F prime of 4. What's F prime of 4? 1/3. So we got 1 over 1/3. Dividing fractions is easy as pie. Flip the second, multiply. We're going to get 3 here. It's not worded that bad. Okay. Yeah. Okay. All right, so let's look at this. All right, so I'm going to show you 2 ways to do this, and that's probably what we'll have time for today. So it says, first of all, it says, what is the value of F inverse of 3? Okay? So if it's F inverse of 3, then that's telling me that the y in the original function equals 3, right? So that would be 3 equals 1/4 x to the 3rd plus x minus 1. Not that easy to solve, right? You could, but it's not going to really get you anywhere. So you got a couple. That would be finding F of 3. Because, no. You're looking for, because see, this is the y coordinate of the, yeah. So we want to know which one will give us the y coordinate of 3. So you got a couple options here. You could kind of guess and check on this. So guess and check is actually not a terrible idea here. What do you think? Let's try 1/4 times 2 to the 3rd would be 1/4 times 8, which is 2 minus, plus 2 minus 1. So plus 1. Yeah, this is going to work. So x equals 2. It probably will not be if it's on the AP exam on calculator inactive. If it's calculator active, you could just solve it on the calculator. So it won't. So it should be a whole number, and it should probably be a whole number less than 5, I would think. The other thing that you could use there is synthetic division. But honestly, I think we're probably better off just guessing and checking. I'm not going to go through it right now because we're about out of time. But I may show you at the beginning of class tomorrow. I
feel like for the AP exam, they're going to do that, but they're going to put it over like cube square root of x.
No, I think table problems are more likely to show up like the one we did before, actually. But if you see something like this, you can probably guess and check it. Okay? F inverse of 3. Inverse of 3 is 2. Okay, so we're supposed to find the derivative of f inverse of x at x equals 3. Okay, so derivative of f inverse, that is telling us to find f inverse prime of x. Right, which, so you got a couple options on how to do this. I'm going to show you 2 ways. The first way is that you could use the formula that we just used. Okay, so you could do 1 over f prime of f inverse of x, which we're plugging in. I'm going to go ahead and plug in here. We're plugging in a 3 in this case. So 1 over f prime of 2, because f inverse of 3 is 2, we found, right? And so we got to find f prime of 2, which we can find f prime fairly easily because it's just a polynomial function, right? So f prime of x, yeah. F prime of x is 3/4. All right, so we got 3/4 x squared plus 1. And so if we wanted f prime of 2, we'd have 3/4 times 2 squared. I said 3, but it's supposed to be 2 plus 1. So that ends up being 3 plus 1, which is 4. So we get 1/4 as our answer here. Okay, that's one possibility of how you can do it. All right, here's another option you may or may not like. Okay, so you can get by with doing the formula every time. The big problem with the formula is you have to have the formula memorized, and it's hard to remember sometimes, and get the inverses and the primes in the right places and everything. The other option you have is this. Whenever I want to find an inverse, I switch my x and y's, right? So if I do this, if I do x equals 1/4 y cubed plus y minus 1, this is now my inverse function because I switched my x and y's. Can I take the derivative of that? I can use an implicit differentiation. I'll have 1 right here. I'll have 3/4 y squared dy dx plus dy dx minus 0 there. You're going to have the formula if it's a table problem, so probably formula, but here's just an alternate option. So my dy dx, if I factor it out, I've got 3/4 y squared plus 1. And so my derivative is 1 over 3/4 y squared plus 1. So this is the derivative of the inverse. And so you could just plug 3 into this. You don't have to use it. You would have to use, so since 3 is you would not plug in 3 because there's no x in this equation. So you would have, like, our point here is 3, 2, so you plug in 2. So 3/4 times 2 squared plus 1 is going to be 1 over 3 plus 1, which also gives you 1/4.
So just use the formula. So
It's up to you. Yeah.
So finding the value of f inverse of 3 is required regardless of the way that you.
Yeah, you're gonna have to do that one way or the other. Either way, you're gonna have to find that to do either method. Okay. So your assignment for tonight is 186, 1 through 10, and let me look at this real quick. Okay. Hold on, let's see. Let's actually make this 1 through 3, 5, 7, and 10. So the problems are like this problem that we did here. It's not going to tell you got to find that inverse value, but you have to find that inverse value first, and then you can either use the formula or use implicit differentiation. Probably the formula is a little easier.